Okay, so we should be on page 47, and on the right hand side you are going to write your anchor chart. We're going to learn our very first strategy for division. This strategy is called the lucky 7. So on the top of page 47 you should write the lucky 7. Some of you guys might start recognizing this once we start doing it. It is similar to, some people call it the partial quotients, and so that is what some people refer to as. I refer to it as a lucky 7 because we draw a ginormous 7 to solve it. So up here we have our vocabulary. Our dividend is the number that's getting divided up. Our divisor is the number we divide by, and the quotient is the answer to a division problem. Okay, so all of those will be color chunked on my anchor chart. The very first thing that we do, and you're going to want to do this anchor chart like be able to work the problem over here. You won't need half of the page, maybe a third of the page, and then write the steps on the other third of the page. Okay, so we have step number 1, which is draw the 7 box. Okay, so we're going to draw the 7 box. And what it looks like is a big old 7. Okay, and then our problem, so step number 1 is draw the 7 box. It looks like a big 7. Our problem is going to be 736 divided by 3. Okay, so 736 is going to be our dividend, and 3 is going to be our divisor. Right? I'll write that when it's time for us to write it, but that's the problem we're going to work with. Our second step is we are going to put the divisor on the outside. So not on this outside, but on the left. We're going to put the divisor on the left and put the dividend on the inside. Okay. So, like I said, my divisor is going to be 3, so it's going to go on the outside, and my dividend is going to be 736. So remember, what we're trying to do is figure out how many 3s are in 736. Okay? So step 1 was we drew our 7 box. Step 2 was we put our divisor, the number that we are dividing by, on the left, and we put the dividend on the inside of our 7 box. Now, this is like an unspoken step that we're going to do. We have to figure out the multiples. What? There's that word again that we talked about way at the beginning of the year. We have to figure out our multiples for our divisor. Okay? And the reason why we do it for our divisor is because we're trying to figure out how many times this number fits into this number. So we find our multiples. So this is always the next step. We always want to find our multiples because it's going to make our job a lot easier. If we don't stop and find our multiples, we're going to have to take time out later to do that. And so we're not going to do that. We're going to stop right now. Once I've set up my problem, I always stop and find my multiples of my divisor. My question though is, how many multiples am I going to need? How many multiples am I going to need? This part is going to go all the way back to place value. How many multiples am I going to need? Well, what's the largest number that can fit into one place value? Whether that be thousandths or hundreds or 10 millions place. What's the largest number, the largest value, the largest digit that can fit into one place value? hopefully we're saying 9, okay? Because I can't have 10. I can't have 10 ones because that means I have 1 10. I can't have 10 hundreds, that means I have 1,000. So the largest value or digit I can have is a 9. That's the biggest one I can have in one place value. So the largest multiples I have to find are from 1 to 9 because I can't have 10 or 12 or whatever in one place value. I can only have 9. So when we find the multiples, we only find up to 9. If I multiply the number whatever times 10, I've gone too far because I can't have 10. I can only have up to 9, okay? So does that make sense? Hopefully, if not, we'll be talking about it. But I'm going to find the multiples of my divisor, which is 3. So I'm going to go, and when I find the multiples, I do what kind of counting? I skip count, so I'm going to skip count. We have 3. Hopefully you're saying it, so I'm not just doing it. 6, 9, 12, 15, 18, 21, 24, 27, 30, 33. Should I stop or should I keep going? I should stop. I should have stopped all the way back at 27 because I can't have 30 and I can't have 33. All right? Because that's 10 and 11 and I can't have that many in one place value. So division even talks about place value. We don't just talk about place value and then super duper forget it. We use it through everything through math, okay? So we found our 9 multiples. So no matter what strategy you use, you are always going to stop and do this step. This is a non-negotiable piece of dividing. Okay, so we drew our 7 box, we put our divisor on the outside, we put our dividend on the inside, we found our multiples, we are ready to roll. We are going to, step number 3, using your multiples. Hello. Pick large clusters. So large clusters of numbers to take out of the dividend. Okay, so we are going to select large clusters. We're going to use our multiples, our information from our multiples, and we're going to select large clusters, meaning big groups of numbers. And why big and not small? Hopefully we're saying because if we do small, we'd have to do more steps of it. But if we do large numbers, we're going to do smaller steps because we're taking out bigger chunks of the number. So we take out big chunks of the dividend. So this is what we do. We look at this, and we're going to do a lot of covering up in division. So we look at this, and we stop right here. We just only look at the 7. Okay? So cover everything else up in your notebook, and we only are looking at the 7, and we're thinking, there's that thinking piece again, how many times can 3 go into 7? I don't know, math is so hard. We already did all of the work down here. So we come and we look at our multiples, and we go, well, is it once? Because this is 3 times 1. Well, that could work, but we want to take big chunks out. So we're trying to find the biggest chunk. Well, can we take 6 away from 7? Yeah. Okay, can we take 9? No. So the biggest number we can take out is 6. Well, that's 3 times what? 2. So 3 can go into 7 how many times? Twice. But is this really 7? What? Here comes powers of 10. All the things. Is this really 7? No, it's 700. So I'm going to have to put 2 what? Zeros. Okay? So I used my multiple information to figure out how many times 3 went into 7. Well, it went in twice, but this isn't 7, it's really 700. Using your multiples, pick large clusters of numbers to take out of the dividend. This is a large cluster. We're going to take out a group of 200. Okay? Then, our step 4 is we are going to multiply the clusters by the divisor. Okay, so we are going to multiply the clusters by the divisor, just like what we kind of already did. We are going to go 200, big cluster, multiplied by 3. Well, what's 2 times 3? We already did the work. Cello, that's why we do the work. It's 6, but really it's 200. So what's 200 times 3? It's 600. So we are going to subtract 600. Well, I mean, that's what we're going to do. We're not there yet. But so we multiplied 2 times 3, and we got 6, but it's really 600. Now our next step is we are going to subtract from the dividend. Okay, so we're going to subtract this number from the dividend. Well, there's nothing in the ones place or the tens place, so we're going to go 6 minus 0 is, and 3 minus 0 is, and 7 minus 6 is 1. So I'm done. I'm good. I finished. I did one, and I'm good. No, I still have this. That's still part of the number. Well, it's not smaller than my divisor, so I'm going to keep going till it is. So step number 6 is, okay, so I use my multiples to pick large clusters of numbers to take out of the dividend. Then I multiplied my large cluster and then subtracted it. Now I am going to keep, step 6 is, we are going to keep repeating steps 3 through 5 until we get a 0, or a remainder. And a remainder is a number that is smaller than our divisor. So if our remainder is bigger than our divisor, we didn't do something right. Well, right now, 136 is way larger than our divisor. So we have to keep doing steps 3 through 5, which is figuring out how many times this can go in based on our multiples, multiplying the clusters together, then subtracting them until we get either a 0, which is a perfect remainder, or something that's smaller than a 3, which would be numbers 2, 1, or 0. Okay? So we keep going and going. So we do this. We cover this up and we think, how many times can 3 go into 1? It can't, right? So we move over one place. We just only move over one place. So now we have 13. And we have to think, how many times can 3 go into 13? Well, we look down at our work we already did, and we go and we find one that's less than 13 but is close. So here's where 13 would be in between. 12 and 15. Well, it can't be 15 because that's bigger than 13, so it has to be 12. Well, this is what multiple number? This is 1, 2, 3, 4. That means that 3 can go into 13 4 times. But is this really 13? No, it's 130. So we need to make sure we put a 0 back here. And then we multiply this cluster by this number. What's 4 times 3? 12. What's 40 times 3? 120. Look at all the powers of 10, all of the place value stuff. Super still relevant. So now that we've done this, we subtract it from the dividend. And we go 6 minus 0 is, 3 minus 2 is, and 1 minus 1 is 0. Well, is 16 a good remainder? No, because it's bigger than our divisor, which means we can take more groups of 3 out. So we go back to step 3. Using our multiples, we pick out big clusters, and we cover up 6, and we go, how many times can 3 go into 1? It can't. So we move over and we think, how many times can 3 go into 16? We come down to our multiples, see why we did all this work, so we're not guessing. And we look for one that, so it would be in between 15 and 18. Well, it can't be 18 because 18 is bigger than 16. So we come over here. What multiple number is this? It's 1, 2, 3, 4, 5. That means 3 times 5 equals 15. Okay, so we have 3 times 5, and it's really 15 because we're not covering anything up. So then we go 3 times 5 is 15. We're now multiplying the cluster, and then we are going to subtract it. And we go 6 minus 5 is 1, 1 minus 1 is 0. Is 1 a good remainder? Yeah, because 1 is less than 3. So it works. I can't get any more groups of 3 out. So we are done with that step. We've repeated until we got either a remainder or 0. Okay, now what do you think we do? We have all this information over here. What do you think we do? We're going to add them up. Do you see why extra math is so important? We just did a bunch of subtracting. Okay, so you got to practice that. So step 7 is, we add the clusters to get our quotient. Because all these clusters are really baby quotients, just like our baby products of our area model. Okay, so we add our clusters to get our quotient. So we add them, meaning we're going to line them up by place value. We have, let's see, we have 200 plus 40 plus 5. We go 5 plus 0 is 5, 4 plus 0 is 4, 2 plus nothing is 2. So my quotient is 245, but we have to include our remainder, which equals 1. And this means that we have 1 left over. So what this means is that 3 can go into 736 245 times. So we can take out 245 groups of 3, and we will have 1 left over. So let's say I had let's say I had 736 pieces of candy, and I wanted to split them into groups of 3 to see how many I would have. This would mean I would have 245 groups that have 3 in them, and then I would have 1 little piece of candy left over. Okay? So I want you to talk to yourself about the steps of Lucky 7, so that when we come back and I ask you, you don't just stare at me like you don't have a clue of what's going on. So I want you to talk about what you do. I want you to look at what we did over here, so that you're practicing it and it's making sense. All right? When we come back, you're going to need your whiteboard and your marker.